Hi friends, welcome back to Team Education. Friends, in this video we are solving eigenvalues and eigenvectors for the given matrix A. Friends, this topic we are chosen from linear algebra. In the previous video we already discussed the eigenvalues, how to find by using calculator. Now I am discussing finding eigenvalues, also eigenvectors. Okay, you observe friends, given matrix is A is equal to 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3. So by the observation we can say this is having 3 rows and 3 columns. So this is A is a matrix of order 3 by 3. So it is having 3 eigenvalues. Okay, now first to find the eigenvalues we require the characteristic equation of A. So I am writing the characteristic equation of capital A is, we have mod of A minus lambda I is equal to 0. Friends, this is mod, or else we can say determinant of A minus lambda I is equal to 0. Okay, this is the characteristic equation of A. Now here where lambda is, if you are simplified this equation we will get a polynomial in terms of lambda. If you solve that equation we will get the eigenvalues. Here lambda is called eigenvalue of the matrix A. Okay, now mod of A minus lambda I means A, first I am writing A, that is 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3. This is the matrix A minus lambda. What about the I? Here A is which order? What is the order of A? 3. So I order is also 3 only. So this is 1 0 0 0 1 0 0 0 1. Okay, now I need to find out the determinant for this. So this is equivalent to 0. Friends, actually if you directly I will do. Friends, here we can directly write down 3 minus lambda into 1 is lambda, 3 minus lambda. Here minus 1 into lambda into 0 is 0. So you will have determinant of 3 minus lambda, this is minus 1 1. Next minus 1 5 minus lambda minus 1, this is 1 minus 1 3 minus lambda is equal to 0. Because you observe friends, here the diagonal elements only we will get a minus lambda, because here we are multiplying lambda to the identity matrix. Right, now you have to simplify this, then we will get the eigenvalues. I am using a calculator to find this determinant. How can I use means, friends, we have a formula that is lambda cube minus trace A into lambda plus trace of adjoint A into lambda minus det A is equal to 0. Otherwise you can simplify like a determinant method, 3 minus lambda into 5 minus lambda into 3 minus lambda, like this. Okay, or else you can do in this method. This method is very easy friends. Now I am using in this method. First I have a lambda cube. Why I have written lambda cube? This is of order 3. So you will get a characteristic equation in terms of lambda of degree 3. That is why I have written lambda cube minus trace A. Trace A means here, what is A here you have? This is A. Now trace means sum of the diagonal elements, that is 3 plus 5 plus 3. So you will have here 5 plus 3 8, 8 plus 3 11, 11 into lambda plus trace of adjoint A. So first we need to find out the adjoint matrix and then we have to do the trace for that. Okay friends, now I am doing a adjoint matrix A by using the Casio 991 ES model. Based on the student request only I am using this calculator method. Okay, now here the first we have to enter the matrix A value. So friends, you press the setup or mode, both are same here. First we have to enter the matrix A. Here you observe, one is composite, second one is a complex, third one is a statistics, fourth one is a Bayesian, fifth one is equations, sixth one is matrix. So if you press 6 then it will be in a matrix mode. Now you can give a matrix A. Okay, here it is asking matrix, which matrix? I am giving the name as matrix A. Okay, press 1. What is the order of A? We have A is a order 3 by 3. A is of order 3 by 3. So press 1. Okay, now we have to enter all the values. Here we have a matrix elements are 3 is equal to -1. Just you press is equal to button. Okay, now enter a element and press is equal to button. It will upload automatically. Now -1. Here you have a 5, -1, next 1, -1, 3. Now you observe all the values what I am given correct or not. 3, -1, 1. Next -1, 5, -1. Yes. Next 1, -1, 3. 1, -1, 3. Here you observe friends, here it is a cursor. So now I am doing left joystick. Here you have -1, so it is showing -1. Here you have 1, so it is showing 1, right? Now press AC. In generally AC is nothing but it is all clear, but here it is already saved. If you press AC, it will be saved. Once we will verify is it in a calculator or not. So here you observe friends, top of the 4 what I have matrix. So here you observe mat mode. This is nothing but mat mode. Okay, now press shift 4. Why 4? 4 top of the 4 what I have matrix. That is the reason we have to press shift 4. Now we are verifying the matrix is there or not. So press 3 button. Now is equal to button. You observe this matrix is, yes, we have this matrix. Now press AC. Now what I required actually adjoint matrix I required. Okay, so before finding this adjoint matrix I need to find out the determinant. Yes or no? Now determinant is first press shift 4. Determinant, this is dimension data, mat A, mat B, mat C. This is matrix A answer. This is determinant. So press, this is transpose. Okay, press 7. Next determinant of mat A. So again press shift 4. Now I want mat A. Mat A is press 3. Now close the bracket, press is equal button. Then we will get a determinant of A is what? 36. Determinant of A is 36. Is it clear friends? Right. Now write down the determinant A. Now this determinant is not equal 0. So we have det A is equal to 36, and we know that A inverse is equal to adjoint A by det A. Det A is how much? 36. That implies adjoint A if you want to find, then it is better to use 36 into mat A inverse in the calculator. Okay, now matrix A inverse into 36, if you press it, then you will get the result of adjoint A matrix. Okay, so this determinant already I know, so into matrix A inverse. Otherwise you press AC. Now you can write 36 into shift 4 mat A. Mat A means press 3. X inverse butter here you have, press X inverse. Now you observe friends what you did, determinant into mat A inverse. So this is equal to, we are getting the matrix adjoint matrix. What is the adjoint matrix here? 14 2 -4 2 8 2 -4 2 14. So what I required actually trace of adjoint A only. We don't want total adjoint matrix, we want only trace of adjoint A. So how you will get the trace of adjoint A? Just add the diagonals of the adjoint matrix. This is 14 8 14. 14 plus 8 22. 22 plus 14. Here you have a 36. Okay, so trace of adjoint A is 36. Write down now. So trace of adjoint A we have 36. 36 into lambda minus determinant what I have 36. So this is equal to 0. Now we have a characteristic equation in terms of lambda of degree 3. So if you simplify this, then we will get the 3 eigenvalues. Okay friends, this is a polynomial equation, so you can get directly eigenvalues by using the calculator. Now I am using the calculator and finding the eigenvalues. Okay, press AC, go for a mode button or a setup, go for composite. Now we are in a normal mode, previously we are in a matrix mode. Okay, now we required to find the eigenvalues for this characteristic equation. So you have to go for polynomial equation, press mode. Here we are finding the equation, so press 5. Here we have a polynomial equation of degree 3. This is, you observe, a n x. This is the matrix mode. Here it is having a 2 unknowns xy. Here you having a 3 unknowns xyz. Here you having 1 unknown x, but it is a quadratic equation. Now here you having a 1 unknown x with a cubic equation. So press 4. Now you have to enter all the values of a, b, c, d. What is a here? Lambda cube quotient. What is the lambda cube quotient here? You have 1. So press 1 is equal to, next lambda quotient is minus 11. Next lambda quotient is 36. And what about the constant here? You have minus 36. Press is equal button. Again you press is equal to. Now we are getting x1 is equal to 6, again x2 is equal to 3, and x3 is equal to 2. So here you have 6, 3, 2, which implies the eigenvalues of the given matrix A are 6, 3, 2. Okay friends, here I have written the given matrix A and the corresponding eigenvalues what we have. Okay, now we are finding eigenvectors to the corresponding eigenvalue. Okay, first you observe friends, we have to consider x is equal to x1, x2, x3 or x is equal to xyz be the eigenvector corresponding to the eigenvalue lambda. Then we have a, from the definition, ax is equal to lambda x, or also this is a minus lambda I into x is equal to 0. So if you simplify this equation, then we will get the eigenvector. Okay, now I am considering for lambda 1 is equal to 6, we are finding the eigenvector. This is a minus lambda 1 into I into capital X is equal to 0, which is implies a minus 6I into capital X is equal to 0, which gives the eigenvector corresponding the eigenvalue 6. Okay friends, we have a minus lambda I is 3 minus lambda minus 1 1 minus 1, 5 minus lambda minus 1 1 minus 1, 3 minus lambda. Okay, now in place of lambda I have to substitute 6, then I will have 3 minus 6. 3 minus 6 means here we have a minus 3, next minus 1 1 minus 1, 5 minus lambda. 5 minus lambda means 5 minus 6. 5 minus 6 is minus 1 minus 1 1 minus 1, again 3 minus lambda. 3 minus lambda means 3 minus 6. 3 minus 6 means minus 3 into capital X. Capital X is where you have x, y, z is equal to 0, 0, 0. Friends, here you observe, to find the eigenvectors, first we have to use the first diagonal element. By using this first diagonal element, we have to make the below the diagonal elements are 0. Okay friends, now I am applying the elementary row operation. First minus 1 I am making 0. You see how I am doing? That minus 1 is in the second row. So R2 tends to 3R2 minus R1. So friends, here you can do in two types. I can multiply this one with 3 and I can divide the entire row with 3. If I divide it, then it will be complicated. It will be lengthy. So due to that reason, just I am multiplying 3 and subtracting. So this will be minus 3 and minus of minus 3 means plus 3. So this below the diagonal element will be 0. Next you have a third row also. So R3 tends to, just you multiply 3, then I will have 3R3. Here already you have minus, so add just R1. So R3 tends to 3R3 plus R1. Right? Now the first row is as it is, there is no changes. Next second row, here what I am doing, multiplying with 3 and I am subtracting. Okay, so minus 3 plus 3, this is 0. Next minus 3 plus 1, minus 3 plus 1 means what? Minus 2. Next this is minus 3 minus 1, minus 4. Next coming to the second row, next coming to the third row, here I am multiplying 3 and here I am multiplying 1. So 3 times of 1 is 3, 3 minus 3 is 0. Next this is minus 3 minus 1, minus 3 minus 1 means minus 4. This is minus 9 plus 1, minus 9 plus 9 means minus 9 plus 1 means minus 8 into x, y, z is equal to 0, 0, 0. Next here you observe friend, the second diagonal element here you have minus 2. So by using the second diagonal element, make the below the diagonal element are 0. For that I am applying a row operation, that is R3 tends to, here you have minus 4, here you have a 2. So multiply this one with 2, that is R3 tends to R3 minus 2R2. If I multiply with minus 2, it will be 4. So minus 4 plus 4 will be 0. For that purpose only I am multiplying minus 2. Now the first row, are you applying any operation? No. So this is minus 3 minus 1 1. Next second row is also, are you applying any operations? No. So as it is, write down 0 minus 2 minus 4. And the third row here you observe, I am applying the operation R3 minus 2R1. This is 0. Okay friends, 0 minus 0 is again 0. Next R2 we are applying, not for R1. Okay, if we are applied for R1, what will happen? You know, this is this 0 term will be non-zero. Okay, that is the reason we have to use the second diagonal element only. Okay, next minus 4 here. What I'm doing first, you see friends, here I am writing minus 2, so minus 4 minus of minus plus 4, this is 0. Next minus 8 minus of minus plus 2 4s are 8, so minus 8 plus 8 is 0 into x y z is equal to 0 0 0. So friends, here you observe this is upper triangular matrix, that is below the diagonal elements are 0. So now we have to apply back substitution method. Okay, here I am applying back substitution method. If I am applying back substitution, you observe friends, 0 into x 0 plus 0 into y 0 plus 0 into z is equal to 0. So no need to write this one. Next 0 into x 0 minus 2 into y minus 2 into y minus 4 into z is equal to 0. Okay, this is the back substitution. Again one more, you have one more equation. What is that? Minus 3 into x, next minus 1 into y, next plus 1 into z is equal to 0. Okay friends. Okay friends, here you observe this is 2y is equal to minus 4z. We can write 2y is equal to minus 4z, then y is equal to minus 2z. Okay, now here you observe friends, y is in terms of z. Actually, what about this rank of the matrix? Rank of this matrix is 2, because after applying elementary row operations, the below the row as means the third row is 0. So by using echelon form, you can say rank of this matrix A is 2. And what about the number of unknowns here? X, Y, Z. So number of unknowns are 3. So you will get Li solutions. Do you know how many Li solutions we will have? N minus R Li solutions we will get. So here N is a number of unknowns and R is a rank. So you will get a 1 Li solution. So let us consider that Li solution Z is equal to K. Li means linearly independent. So let us consider Z is equal to K is a linearly independent solution. Then Y is equal to minus 2K. Now I got the values of Z and Y. So by back substitution, the first row will be minus 3x minus y plus z is equal to 0. Now you substitute this y value and z value, then we will have minus 3x. What about the y? Minus 2k. So minus of minus plus 2k plus k is equal to 0. So this is, if you simplify this, minus 3x is equal to minus 3k. So we will get x is equal to what? K. Now you substitute x value, y value, z value in the matrix capital X. Then capital X is equal to, we have x, y, z. This is equal to, x means k, y means minus 2k, z means k. So if you taken k is a common, then we will have k quotient is what? 1. K quotient is what? Minus 2. Here k quotient is what? 1. Therefore, the corresponding eigenvector for lambda is equal to 6 is 1 minus 2, 1. For lambda is equal to 6, the corresponding eigenvector x is 1 minus 2, 1. Similarly, we need to find out the eigenvalues for lambda is equal to 2 and lambda is equal to 3. Now I am doing for lambda is equal to 2. Okay friends, again I have written a minus lambda value here. Okay, next for lambda is equal to 2, the corresponding eigenvector, we have a minus lambda 2 into I is equal to capital X is 0. What is the lambda here? You have 2. So a minus 2i into x is equal to 0, where capital X is x, y, z. Now we have to substitute this lambda value in this equation. Then we will have a minus 2i into x is equal to, this is 3 minus 2. 3 minus 2 means 1 minus 1, 1. Next minus 1, 5 minus 2. 5 minus 2 means 3. This is minus 1. Next 1 minus 1, 3 minus 2. 3 minus 2 means what? 1. Into, whatever the capital X? Capital X is x, y, z. Okay, this is equal to 0. What is 0? 0 row is 0, 0, 0. Now, friends, by using this first diagonal element, we have to make the below the diagonal elements are 0. We have to apply the elementary row operations. We will get a echelon form and then we will get the values of x, y, z by substituting back substitution method. Okay, by applying the back substitution method. Now, I am applying the elementary row operation to make the below the diagonal elements are 0. For that, first I am applying R2 tends to R2 plus R1. Next, R3 tends to R3 minus R1. Okay, now the first row is 1 minus 1 1. Second row minus 1 plus 1 is 0. Next 3 minus, just what we are doing, adding the second row with the first row. So minus 1 plus 1 is 0. 3 minus 1 is 2. Minus 1 plus 1 is 0. Next third row, what I am doing, R3 minus R1. Just subtract here. 1 minus 1 is 0. Next minus 1 minus of minus 1. So 0. 1 minus 1. Here you have a 0. Okay. Friends, here you observe the third row and first row both are as it is. So if we subtract it, then we will get a 0 only. Is it or not? Now, what about the x here? X, y, z is equal to 0, 0, 0. Okay. Now, I am applying back substitution method. Now, below the diagonal elements are 0. So, you apply the back substitution method. And moreover, you observe what is the rank for this matrix. Rank is here. Rank of A is here. I have 2 because the number of non-zero rows are how many? 2. Here 1 0 row is there, 2 non-zero rows is there. Now, what about the number of unknowns here? X, y, z 3. So, what about the linearly independent solutions? We have the linearly independent solutions are n minus r. N minus r means 3 minus 2 means one linearly independent solution we will get. In x, y, z, any one of them you have to take as a linearly independent. Okay. Now back substitution method I am applying. Back substitution means 0 into x 0 plus 0 into y 0 plus 0 into z 0 is equal to 0. So no need to write this equation. Next second one, what I have, 0 into x 0 plus 2 into y. So 2y plus 0 into z 0 is equal to what I have, 0. So from this what you can say, y value is 0. Next you have a first row, 1 into x minus 1 into y plus 1 into z is equal to 0. Friends, already we know the value, y value. What is the y value here? 0. So x plus z is equal to 0. Here you have a 2 unknowns, but one equation only we have. Friends, we know that one independent solution is there. So let z is the independent solution and consider z is equal to k. Then x plus k is equal to 0. We will have x is equal to minus k. Okay, friends. So x value I know, y value and z values, these three values I know. So the corresponding eigenvector for lambda is equal to 2. I am considering as a x2, which is equal to, we have x2 is xyz. So this is equal to, x value is minus k and y value is 0. Z value is what we have, k. So from this I can take k is a common, then I'll have minus 1 0 1. Therefore the second vector x2 is minus 1 0 1. What we got the first vector, that is x1 is 1 minus 2 1. Now we need to find out for lambda is equal to 3 the corresponding eigenvector. Okay. Okay, friends, we have a mod of a minus lambda is this one. For lambda is equal to 3 the corresponding eigenvector is a minus 3i into x is equal to 0. Okay, friends, now I am substituting lambda is equal to 3 in this equation. Then I will have 3 minus 3 is 0, minus 1 1. Next minus 1, 5 minus lambda means 5 minus 3 means 2, minus 1 1 minus 1, 3 minus 3 means 0. Okay, now I have to simplify this. Friends, now I am applying elementary row operation. First diagonal element what I have actually 0. So interchange the first row and second row. Interchange the row 1 and row 2. Then we will have minus 1 2 minus 1. Okay, what about this? 0 minus 1 1 1 minus 1 0 into x y z. Okay, which is equal to 0 0 0. Now use the first diagonal element, make the below the diagonal elements are 0. Already second diagonal element is below the diagonal element is 0 in the second row. So now the third row means applying R3 tends to R3 plus R1 because 1 minus 1 will be 0. Okay. Now first row and second rows are as it is because we are applying elementary operation for the third row. So 1 plus 1 1 minus 1. 1 minus 1 means 0. Minus 1 plus 2 means 1. 0 minus 1. Just adding here. Okay, minus 1 into x y z is equal to 0 0 0. Now see the second diagonal element what I have, minus 1. So by using second diagonal element, make the below the diagonal element are 0. For that you apply the operation, row operation, that is R3 tends to R3 plus R2. Then we will have first row as it is. Okay, and what about the second row? Second row is also as it is, because we are applying operation on third row only. So third row is R3 plus R2. 0 plus 0 is 0. 1 minus 1 is 0. Next, minus 1 plus 1 is 0 into, here we have a x, y, z is equal to 0, 0, 0. Now you observe this is the upper triangular matrix type, and you observe, friends, below the third row is what? 0 row. Okay, so you can say rank of this matrix is 2, and the number of unknowns here we have 3. So we will get the Li solutions are n minus r. What about the n here? 3. What about the r here? 2. So 3 minus 2 means 1. So we will have one independent solutions. Means any one of xyz we have to consider as a independent. Anyhow, now applying back substitution method. Now this third row is already 0. So 0 into x plus 0 into y plus 0 into z is 0. Next one, 0 into x, 0, minus 1 into y, that is minus y, plus 1 into z. So z is equal to 0. From this, what you can say? Y is equal to z. Friends, we know one independent solution. Yes or no? So let z is equal to k. That implies y is equal to also k. Y is also k. If you consider z is equal to k, then we are getting y is also k. Now again one more row is there. Multiply here. Then we will have minus 1 into x means minus x, 2 into y plus 2y, minus 1 into z minus z is equal to 0. Now we already know the values of y and z. So if we substituted, then minus x plus 2 minus k is equal to 0. This is plus 2k, this is minus k. So you will have a plus k, which implies x is equal to, here we have a k. So here x value, y value, z value are k. Therefore the corresponding eigenvector for lambda is equal to 3 is x3, which is equal to x, y, z, which is equal to, x value is k, again y value k, z value also k. So if you taken k is a common, then we will have 1, 1, 1. Therefore the third eigenvector what I have? 1, 1, 1. Therefore x3 is equal to 1, 1, 1. Okay friends, now I am writing the given matrix A, and the corresponding eigenvalues we have lambda 1 is equal to 6, lambda 2 is equal to 3, lambda 3 is equal to 2, and the corresponding eigenvector for lambda 1 is equal to 6 we have a x1. X1 is 1 minus 2 1. Next, for lambda 2 is equal to 3, the corresponding eigenvector we are denoting with x2, where x2 is 1 1 1. And for lambda 3 is equal to 2, the corresponding eigenvector we are denoting with x3, and this x3 is, we have 1 0 minus 1. Okay friends, is it clear for everyone how to find out the eigenvalues and the corresponding eigenvectors?